Hi, I'm Sarah Mannion from NVIDIA, and thank you, Duncan, and all of the team at Thames Valley IoT Meetup for having us here today. It's an absolute pleasure to talk to you all. So what I want to do over the next 20 minutes or so is to really take you through the work that NVIDIA are doing in the autonomous object space, and also want to share with you some of the tools and resources we have that are freely available that you can use to make your own autonomous objects. So let me share my screen and get started with the presentation for you. To start off with, I wanted to talk a little bit about NVIDIA and who we are, because I'm sure there are many of you who didn't know that we actually worked in the autonomous object space. So I just want to take you through the company and our business areas and really share with you what our focus is. So hopefully you all know us from gaming. That's absolutely our pedigree and our background. And that's where we started, inventing the GPU in 1999. Those of you who remember games like Doom, Duke Nukem, those fast-moving shoot-'em-up games, that's where our history came from. Because we developed the GPU to power those very fast-moving games. Graphics processors at the time really couldn't keep up with the demands of those games. And of course, whoever had the fastest and best graphics processing won the game. And if you know GeForce and perhaps now Titan, that's the branding that we use in the gaming and the consumer sector. But we also have a huge part of our business dedicated to professional graphics. So all of those users of applications like Autodesk, SolidWorks, CAD/CAM type applications, because they also have really quite intense graphical demands. And so we have a range of solutions called Quadro that really fit those business needs. And what we do with our Quadro range is we work with those application vendors so that we can certify our driver with their application so they know it's supported and it works on an NVIDIA GPU. And we've continued to do that when we've branched out into working with artificial reality, virtual reality, augmented reality. So the graphics side of our business, many of you I'm sure know, but we also really have been focused the last few years on the data center, and that's our Tesla brand of GPUs. And Tesla GPUs really started for machine learning, number crunching, compute intense operations in the data center. Tesla now supports anything in the data center, whether that's virtual workloads, virtual desktops, virtualized AI, any form of whatever you want to run in the data center. Tesla is the acceleration platform for that. And in the same way that we work with ISVs for the graphical applications, when it comes to Tesla, we make sure that those GPUs are validated to run 24/7 in the data center. So they come with warranty and support and the testing that you need to know that you can rely on that GPU to run intensively for 3-4 years. And then the area of our business that really I'm sure most of you want to hear about is the autonomous object side of the business. And we've worked in the mobile area for a long time. So using our Tegra GPUs in mobile devices, this has now started to broaden out into small GPUs or small computers that run in autonomous objects. The real theme here is that all of these business areas of ours all use the same solution, and that's the NVIDIA GPU. Now, I know that we had quite a lot of talk today about vehicles, so I wasn't going to spend too much time talking about that, but I did want to share with you the work that we are doing on the autonomous vehicle side. What you can see here is BB-8, and you can see how we built a platform with hardware and software and taught a car how to drive itself. And you can see the hilarious footage here as the car is learning and all of the mistakes it makes as it's developing its learning. And you see here, this was some time ago, this is March 2016. And this is when, after many, many thousands of hours of learning, we have a situation where we now have a car that can drive itself. And this is a platform that we call NVIDIA Drive. And you can see on the left just some of the 380 automotive companies who have chosen to use NVIDIA Drive. So I wasn't going to go into lots of automotive side of autonomous objects, because obviously Simon and Isaac are talking about the automotive side of their respective businesses. But I wanted to just show you what we are doing in that space, and really to make the point of, why are all these organisations choosing NVIDIA and NVIDIA Drive? Well, because you need the fastest decision making possible when you have an autonomous vehicle on the road, and that's what we deliver, and that's what we do. Fundamentally, this is what GPU acceleration does. GPUs don't replace CPUs. So this isn't a case of, we are replacing that technology. It's complementary. It's a supercharger. CPUs are very sequential, single process. Take a job, complete it, and then take the next job, complete it. GPUs are very much suited to running multiple processes at once, parallel processing. And that's great for certain workloads like graphics, but also for machine learning, deep learning. And so what you see here is how that combination works to supercharge the processing. All of the application code, assuming it's GPU aware, will be offloaded to the GPU. So the GPU can process the bits of code that it's really good at, that parallel processing, leaving the CPU free to do all of that sequential code that it's really good at. To give you a more of a layman's example, think about natural language processing. Many of us are familiar with this, Alexa, Google. But if you think of the complexity of what you're asking, if I say, hey Alexa, play AC/DC, she's got to first of all figure out that I'm asking something of her, not just talking in the background, and then understand, what have I asked? Am I asking to play a game, to play music, to play a radio station? And even if she knows that that's the name of a band, is it the band? Is it the title of the album, title of a track? Sometimes they're the same. So there are lots of different computational processes to go through. Think of it as like this huge decision tree, lots and lots of things to think about and to process. And that's where parallel processing really makes a difference. And what you see here on the right-hand side is an example of compute latency in doing natural language processing. And this is BERT. And there's a link at the bottom here where you can go and access and you can read all about this. But what we're showing here is that for executing BERT natural language processing, to do it on a CPU or CPU server, 40 milliseconds. Adding a GPU into that reduces that time to 2.2 milliseconds. The other way of saying it is it's 17 times faster. And that's really important when it comes to something like natural language processing, because time matters when you're waiting for an answer. And this also helps to make these kinds of applications of AI really tangible as a service, so that you have that real-time AI. So hopefully that just gives you a little bit of an example of how a GPU accelerates AI processes. And that is going to be really important going forward. We're all here today to talk about IoT and the future. And certainly I've seen that there are smart devices in almost every home now. How many of you have got smart meters for your utilities? Maybe you've got Nest to control your lighting. And that is just growing and growing. And then we have the advent of 5G, the ability with increased bandwidth to deliver even more intelligence, because we can push more data around. And that will really help us get to this connected edge, because it's one thing having smart sensors and telephony and all sorts of things, but what you need is the ability to have real-time decision making. The example I always give is CCTV cameras. There are millions of them around. but all they do is record stuff. If you want to have a camera that can be smart, that can detect a certain input and then do something about it, it's got to be able to make that decision in real time. It can't really rely on a very long trip to the data center to get an answer of what it should do before it can implement that, because most of the time, whatever it's looking at will have disappeared by then. So having that fast processing at the edge is absolutely essential for going forward with smart edge and the predictions of AI in the future. Now, what I want to do is share with you some of the work that we have been doing. And I'll just play a little video, but this will show you some of the customers we're working with, but also some of the use cases. So I'll kick this off now. So you can see in the left-hand corner, you'll see the names of the customers that are being featured here. And drones are a huge part of this. As I mentioned, taking photos or taking video footage is one thing. You had to do something with that input. That's the AI part. Same for autonomous delivery vehicles, the ability to interact with them. So hopefully that gives you, a few ideas and some examples of where we are working with customers and in what sort of aspect that we're using the technology. And so I want to talk to you just a little bit about what that technology platform is. And our platform really focuses on the end-to-end of AI, because we're talking very much here about the edge and smart edge and autonomous objects. But before we can have anything at the edge, we need to train it, and training it generally in the data center. And our platform is really focused on that entire journey. So, not isolated in terms of just the edge or just the data center. We have a single platform that covers the whole journey, from the training and the simulation to the deployment at the edge, and of course that ongoing inference and future iteration and updates at the edge as well. I'm not going to talk a lot about our hardware and our GPUs, but for those of you who do want to know, these are our GPU recommendations for AI. When it comes to the data center, that's our Tesla brand that I talked about earlier. And we have our V100, it's our most powerful GPU yet, and that goes inside our DGX, which is our deep learning supercomputer. So it's an appliance, almost ready to go, focused completely around deep learning, works with all of the common frameworks. We also have our Tesla T4, which is a smaller GPU that's suitable for running quite a lot of workloads, but is also really good for inference and for smaller scale projects. Now, both of those GPUs are available in the public cloud. So if you are using someone else's data center, whether that's Amazon, whether that's Azure, Baidu, Google, Tencent, whoever, they all have our GPUs. So you can start doing that development work on training wherever. And whenever you're ready to move it to the edge, all of that work that you've been doing moves over to the edge. And we have different GPU applications there. You can use the T4 at the edge, but we also have our Jetson family, which are much, much smaller devices. But they're not just GPUs, they're effectively mini computers that can be fit into all sorts of edge devices and robotics. And Jetson effectively are small computers with CPU, GPU, memory, Wi-Fi, all built into a very, very small unit. And that family is very, very similar to the platform we use for NVIDIA Drive to power autonomous objects. But this is very much about hardware. And what I want to talk to you about actually is the software, because many people think of NVIDIA and they think of the hardware element, but we have a huge, huge element of software. And if you remember one thing from my session, one thing, it's this: ngc.nvidia.com. And what is that? It's our GPU cloud. So think of it as a repository that contains all of the building blocks you need to build your environment. So on NGC, we have containerized instances of all of the popular deep learning, machine learning frameworks that have all been customized to work perfectly with our GPUs. And we maintain and update those. But we also have libraries, pre-trained models, scripts, even data sets. So we have everything that you need to go and start building and developing. And best of all, it's free. You just need to go and register. And wherever you want to do your development, if that's in the cloud, that's fine. Log into NGC, you can go and grab all of those pieces. And then when you're ready to move out of the cloud, whether you want to scale that up, put it into your data center, or take it to the edge, you continue to use that same software platform. So ngc.nvidia.com. The other piece I want to draw your attention to is developer.nvidia.com. And that's the resource for your developers for building applications. And that's what I want to show you today. I want to show you 2 SDKs that are focused around autonomous objects. And again, these are completely free. And I want to show you the capabilities of what you can do here. So what I want to start off with is introduce you to Isaac. And Isaac is our SDK for building autonomous objects. And there's a lot to Isaac, but to put it quite simply, these are all of the tools that you need from scratch to build autonomous objects. And a huge part of that is the simulation environment. And what we mean by that is we build a virtual world for the robot. And we even build a virtual robot or autonomous object. Because if you were to start building your autonomous object, it's got to learn how to operate in its environment. But you can't necessarily have 100 new autonomous objects roaming around a factory floor because it's not practical. So we build a virtual environment so that they can learn how to execute against their code, they learn how to navigate, and they go through that development cycle. And when the virtual robots can navigate the virtual environment, we can put that into the real world. Let me give you an example. Let me show you this in terms of a robot that we were working with and teaching it to play hockey. So let me show you this. So you can see the robot knows it's supposed to play hockey, it's supposed to get a goal, and it's trying, it's learning. And again, reinforcement learning, it knows what it's supposed to do, and when it gets it correct, that really speeds up its ability to achieve that goal. It knows what it's doing, and it gets it right more and more, and faster and faster. But because it's virtual, what you can see here is that we can actually spin up multiple instances of that virtual environment. And each one might operate slightly differently, but what you'll get is, rather than just having the one virtual environment, you can have 20. And you take the learnings from all of them and put that back into your model. You're continuing to refine, but you're really shortening that development cycle because you're testing in so many different ways and putting all of that knowledge and richness back in. And so what will happen eventually, and what you can see here is, this is the real robot. And with a trained model, you've cut that development cycle, and the robot has a much better understanding of what it's supposed to do, and you can see faultless, hitting the goal each time. So that's just a little bit of an overview of Isaac Sim as part of the Isaac SDK. And you can see there's the address there if you want to go and download it, completely free. To give you a little bit more of an insight of what Isaac looks like, you can see here, this is just a very small part. And what you're looking at here is the part where we are teaching a robot, this one here, we call Carter, and teaching him how to navigate. And this is all through his camera. And what you see at the top, this map view, this is a map of our building, our headquarters in Santa Clara. And you can take maps like this, and they're taken generally with just 1,000 pictures using cameras. Build up that map, put that into the application, and you have a map that the robot can learn where it's supposed to navigate, what all of the pathways are. We've worked with a number of customers who also use this. So BMW, as an example, building robots to help them maneuver parts around the factory floor. And they did this because they can't really have 100 robots going around the factory floor learning. So they went around with a load of laser scanners, took images of the production floor, put them into Isaac. They're teaching the robots about where they're supposed to dock. And then once they've been taught, then they can start to go out onto the factory floor for real. And so that's what you're seeing here. This virtual floor plan and the ability to start to train and teach that robot, the virtual representation, how to navigate this virtual world and this virtual map. So the last little piece that I wanted to share about this, and on the subject of the Carter robot, is the SDK really is also about teaching you to build robots or autonomous objects completely from scratch. And what you can see here is some of the example tutorials, so step-by-step tutorials with all the code that you need to learn how to build your robot, all of the components, so it goes through sectionally, LiDAR, every single piece, obstacle detection. It even shows you the pieces you need to buy to build the robot. And of course you've got the sim, the virtual world. And it's got all of the DNNs for segmentation, object detection. It's just waiting for you to just go and learn how to do it. And if you don't want a big robot like Carter, we have a much smaller one called Kaya. It's like the size of a remote control car, a really, really fun project. So if your kids are looking for something to do over the holidays, it's a great example. So that is Isaac, and a fantastic SDK. And what I'd like to do is to share with you one more SDK, and that is Jarvis. And Jarvis is our multimodal AI SDK. So joining together vision, voice, and loads of other inputs. You'll understand in a minute when I show you where the name comes from. So I won't try and explain it, I'll just show you.
Hey, do you want to get some food?
Yeah, actually, I'm pretty hungry.
All right. Find us a Mexican restaurant.
The nearest Mexican restaurant is Luna Mexican Kitchen, located at 1495 the Alameda, San Jose.
How's the weather in San Francisco?
It is currently 66 degrees and sunny in San Francisco.
Actually, you know what? I'm kind of feeling sushi.
Really?
Yeah.
All right. Show us a Japanese one.
The nearest Japanese restaurant is Aniki Sushi, located at 3810 Mori Avenue, Fremont.
How about tomorrow?
It will be mostly cloudy with a high of 62 and low of 54.
What's the rating?
Aniki Sushi has 4 stars on Yelp.
That's pretty good. All right, show us the directions.
Here are the directions to Aniki Sushi.
Nice, I'm excited. I've really been craving sushi.
Yeah.
So hopefully you can see there what Jarvis is all about. And I think the things you hopefully notice are no wake word. It's not like Alexa. It's tracking the conversation and the facial recognition. But the key piece is how it can track the 2 different conversations and then when they join together. So you see Shirley asks the question about what's the rating in relation to what Alex was asking about the restaurant, and then she says straight after, what about tomorrow? Because she's finishing off her conversation about the weather, and Jarvis can track all of that. And this is a really, really exciting SDK. Again, there's the web address. You can download it from the developer section on our website and start building these multimodal AI applications. And where we see this really being of interest is retail, the ability to interact with some form of shopping assistant, but also manufacturing. And a lot of robots in factories today are actually in cages because they're not aware of their environment. And the idea of having cobots that you can really interact with is not only something that's great from a safety aspect, but also from a productivity aspect. Imagine using this to say to a robot or some form of autonomous object, pass me that spanner. No, not that one, the blue one. And how useful that kind of application would be. So this is our SDK, open and available. Go and download it and take a look. So that's what I wanted to share with you. Just a couple of the tools, the platforms, the SDKs, all freely available to help you build autonomous objects. And just to reiterate, this is our platform. So the NVIDIA GPUs and the resources that I showed you, the SDKs that are available on NGC and on Developer. And that is an end-to-end platform. If you start developing on your Titan GPU at home, as long as you're using NGC, all of that goodness, when you want to scale that up to a bigger desktop computer or the cloud or a data center, then all of that work will follow along with you. So I know I'm nearly out of time, so just the last couple of things that I wanted to share is 2 days to a demo. If you're interested in what you've seen and you want to learn how to build autonomous objects, you want to learn a little bit about deep learning, go to this website. And in 2 days, know nothing, you can build a whole working demo. Best bit is, if you don't have 2 days, you can go and get one of our pre-trained models. You can do it in about 2 hours, but completely free resource. So you've basically got a 2-day course, completely free. Just want to share again those websites that I mentioned, NGC for all of your building blocks, Developer for the SDKs and for building out those edge solutions on Jetson. And I want to give a little shout out to DLI, so nvidia.com DLI, Deep Learning Institute, where we have free and paid for, online and in person, after current COVID-19 situation, deep learning training. So we will teach you with qualified instructors how to do all of the technical coding and know-how, how to really build these applications. And we do that across all sorts of different industries and machine learning as well as deep learning. So take a look at DLI if you really want some instructor-led or classroom-led training on how to do this stuff. And questions. If you have questions for me, please put it into the Q&A, and we're going to go and do questions right at the end after all the speakers have presented. Thank you very much. It's been an absolute pleasure. And if you have any questions, feel free to get in touch. Thank you.